Welcome to our latest webinar that we're looking at retrofit and decarbonisation and issues that's quite close to the Northern Consortium's heart. We're putting a lot of work into our policies around decarbonisation, and this is one of a series of webinars we've been holding. I'm going to hand over to my colleague Liam, who will give us a description of what's going to be going on this morning. We do like interaction with you. There is a Q&A function that you'll be able to see. Please do post your questions there for the speakers as the session's running. I'll pass on to Liam now.
Right, thanks everyone. I'm just going to quickly introduce our speakers here and let you know the topics that we'll be discussing today. So obviously, as Nigel says, just again, thank you to everyone for attending the latest webinar in the series. We're of course looking at the challenges and opportunities posed by decarbonising the North's traditionally older and colder housing stock, and of course that wider climate agenda and where Northern Housing Consortium members fit into it. I'd like to first thank our campaign partners on our North Net Zero. They support everything that we're doing, from member engagement activity like this webinar to the policy and influence and work, as Nigel says. Our campaign partners are Halton Housing, Liverpool City Region Housing Associations, 13 Together Group, and our colleagues at Consortium Procurement. Today's webinar can be seen as the second part of a series looking in detail at retrofit and the range of interventions we'll have to make on our housing stock to enable reaching net zero or making our houses carbon zero ready. Last week, we discussed some of the policy barriers to scaling up home retrofit, and we also heard some case studies on fabric first interventions. So that's like maximizing air tightness, increasing levels of insulation to lower that energy demand and making the structure of the home as energy efficient as it can be. Today is about really looking at how fabric first is one side of the retrofit coin, and today we'll be looking at the other side, that renewable heating technology that residents will be soon relying on to generate energy within their home, reaching net zero and reducing energy bills, for example. We've got a range of speakers today to talk through their work. I'd first like to introduce Charlie Baker from Red Co-op. Charlie's an architect and he's led over numerous years urban design projects and sustainability projects in Manchester. He has a strong expertise in design and how retrofit can be technically excellent, affordable and beautiful at the same time. Following Charlie, we'll listen to Patrick Berry, who will be discussing his work at Together Housing and Together Energy Services. Patrick oversees large-scale energy efficiency investment programs at Together, and he'll be discussing how these projects bring benefits to tenants and develop new sources of long-term revenue. And finally, we have Wes, who's the renewables manager at 13 Group, and Wes's work looks at sustainability in 13's housing and how his role is important in implementing the organization's ambitious climate strategy. Just to quickly run through a few bits and pieces in terms of the practicalities, we'll be tweeting highlights of the event through the hashtag #RNorth on Twitter. There'll be a recording and a write-up of this event for NHC members following on from today's event. You can ask questions, and please do. There's the Q&A function, there's the chat box. Please do make use of those. And if you'd like to speak to us all directly, if you raise your hand, we do have the ability to bring you in to the webinar. And with any time remaining that we have in today's session, if you'd like to raise your hand, we will bring you in and we can have maybe more of a round table if you'd like. Q&A function is still there if you'd like to use that. So at that point, I would happily like to pass over to Charlie, who will be giving us a presentation, and he'll be sharing his screen now. Thank you, everyone. Sorry, Charlie, you're just on mute there.
Right, sorry about that. Joys of trying to make Keynote share over Zoom. Anyway, we're here now. two projects that are pretty germane to this, but I've been in this space for a while. One is the Scaling Up Better Homes Yorkshire that we are just topping and tailing the report to at the moment. This presentation has got quite a few of the slides from that, if any of you were at that workshop on Monday. But there's a few extras just to keep it fresh. And then the other one is then, what? Hold on a second, something's gone quite weird here. Give me a second, everybody. For some reason, it's skipping things. Never mind. The other one is Homes and Energy Systems. This is an EIDF project. I've got a little bit at the end of it to do 20 properties as near to net zero as we can get them. We're trying to see if we can do full net zero, as in including small power, as well as the space heating, hot water, etc. And then the rest of them are having a lot of fun with shared loop ground source heat pumps, a few bits of EWI and batteries, testing things out next to each other. Obviously, I don't need to tell you why we're doing this. We're supposed to be delivering 14.5% reductions per year now. It was 13% in Manchester 3 years ago, but then we didn't do anything. Several people keep saying, well, why are we doing retrofit? Why are we not just waiting for the grid to decarbonise? There are not many tools to prove the argument on this, but the old Mackay calculator is quite good from 2013. There's a nobbled version, the link of which will come up in the next slide. Basically, if you put all of the renewable energy on as far as you can get it, you still have to turn all of the demand reduction sliders right up to maximum to be able to get it to work. So what that means in our case is retrofit the pants out of your houses. What we mean by retrofit, because obviously the term deep retrofit is becoming quite a it's becoming a new term that seems to be contested, let's put it that way. So we're proposing somewhere between 25 and 40 kilowatt hours per square metre per annum. And a lot of the houses I've done have been 5 times that, the one in this slide being one of them. And then if you can get far enough and you've got enough roof space, then put enough PV on the roof to be able to then match the remaining power demand of what you can get off the roof. I think the fundamental attraction for me of retrofit is that opportunity to actually retain our neighbourhoods whilst also then making them healthy and giving people much better prospects. This isn't a photo montage. This is, I only had a client on the right hand side, Mohammed on the left hand side hasn't yet gone, oh, do you know what, Charlie, I'll have it too. And we've got, let's face it, that it's not even once in a century. I think it's just a unique opportunity, obviously in the face of a unique threat. And we shouldn't squander it. We can take those knackered houses. So these are just the technical about what I mean by retrofit. So it's walls to point to. On walls like this, I use wood fibre. I've just tested out a new product that goes on the really, really wobbly walls where you drill into a brick and the fixing doesn't take. So you put some cassettes up first and then you cover that over later. The installers quite liked it. Also, the other thing about a retrofit is you save 50 to 80 tonnes of CO2 compared to a new build. Those aren't my figures, those are Simon Sturgis's. We shouldn't be doing things by just the square meterage. We should be doing stuff by the junctions as well, by the total energy demand. People always say, well, I've got X square meters of gear on the wall, and then they've forgotten about the junctions. You can lose an awful lot of heat out of those, but there are also opportunities for local supply chain to get involved. This stainless steel virgin gutter was made by a fabricator up in North Manchester. Internal wall insulation, where for streetscape reasons or technical reasons you can't do outside. So usually the front wall. Again, in this case, wood fibre because it was an old solid wall property. And then the roof, get them to 0.1 where you can. If someone's got a room in the roof, 0.15 is achievable, 0.2 is fairly easy. Floors are the one that we have some difficulty with. Most of our building trade operatives can't fit through the small hole that yours truly is sliding himself through in that bathroom in the top left-hand corner. But also there's a presumption of running away from the ones that are a bit damp. In this case, there was actually running water. There were puddles of water under the floor. And so we put a floor drain in first before we put the recycled glass pumice in that's completely inert and won't conduct any moisture up. And that seems to solve the problem. We did it 3 years ago. They've not come back to us and said there are any more problems. Windows and doors, very big one. This one uses Green Building Store windows. They're extraordinarily disruptive putting new windows in, especially in homeowners' properties where you've got to do an awful lot of different solutions to different houses. In this one, we tested out, and I'm going to go back to it, pre-fitting the reveals to the windows so that the making good, the wet trade you've got to get in afterwards, is confined to just the join around the window where it meets the inside face of the wall. We've had a devil of a job dealing with reveals one way or the other. In some cases, the houses have already got nice windows people want to keep. So you refurbish the sashes, or you secondary glaze the stained glass, or you remake high efficiency casements with a double seal on them to go inside the original window frames. They call it the Manchester window here. I'm sure in Newcastle they probably call it the Sunderland window, and in Yorkshire they call it something different. But that window that sticks out the back of terraces where the ground floor catches a bit of light, a demon for letting water in and heat out. This one's triple glazed. Quite chuffed with it, worked quite well. Cold bridging and air tightness is the bit that people seem to... Oh, the other point to mention with all the windows is we use triple glazed timber ones. They come with a 10-year guarantee, so you can move your repainting schedule on a few years, and if you look after them, they'll outlast the PVC many times over. The cold bridging and air tightness, we're looking at Y values that are, well, hopefully about a quarter of the usual assumption, which is the one that's built into the SAP software, which you can't change, the RD SAP software, which you can't change unless you do a full SAP assessment. Similarly with the cold bridging, making sure that you deal with those junctions, as I said earlier. The other one we need is better moisture handling. I mean, obviously over the eastern side of the Pennines, the moisture levels are much lower, and it's not as much of a problem. But over this side, an awful lot of moisture is crawling their way around the buildings, and it's causing a lot of issues. We've tried various bits of lime plaster to deal with that. But also we need to make sure that our insulation materials are the ones that deal with where the moisture needs to go. And then the one that everyone misses out is the ventilation. We've been trying to use chimneys a lot to make sure that we reduce the problems there. And where we've got suspended floors, we've been looking at using those voids as part of the ventilation. But you have to be a bit careful about that if they're damp and if there's any mold in them. We're experimenting with MVHR in chimneys as well. The COVID thing stopped me fitting something on the end of that pipework, so I'm due to go back and do that sometime soon. But demand controlled ventilation is the other approach to this. So just above the light on the porch is the demand controlled air inlet, and at the bottom there is a demand controlled outlet that then feeds up into the chimney. The services themselves, we need to make sure we do something nice with them. There's a conventional wisdom that you take the soil stack and you stick it on the outside of the insulation, but really, really doing the job properly. You don't swan naked at the bottom because that's a rather nasty place for a blockage. You even move it below ground, or, as is the case on the left, you actually embed it behind the insulation, put an air admittance valve at the top of just above the last join into it. And obviously by doing it with cladding, if you do have a problem with that valve or a problem with those pipes later, you can just take the cladding off to get to it later. I was asked to talk about low carbon heating solutions as I whistled through this. This one is a zero concrete ground bearing slab. He wanted to put bamboo laminate on top of it. So we had to make sure that the floor surface temperature never got above 27 degrees, which is an awful lot of pipes, but we did do it with no concrete, which I'm quite chuffed with. Don't do this, obviously. We need to make sure that the briefs to contractor design are done properly, so that we can not have that. Although weirdly, this was done in 2011 as part of Retrofit for the Future, and the householder really liked the opportunity to go and play with it all and make it work properly. What we really need is the nice neat things like those plucky Dutch do. This is from Energy Sprong. Put it all in a pod. We did try these 9 years ago as well, but unfortunately the British plumber isn't prepared to stand outside and do the maintenance. They have to have a cupboard they can stand in while this is all happening. The Dutch are happy just to be able to reach into the cupboard. So we put some of the gear in a cold store, and that fits reasonably well. We've tried our hands at ground source heat pumps, and this one controlled by a very clever piece of kit, clever for me. So these down here are the places where the heat pump turned itself on in the gaps in between. It's the pink one, not that one. So there, where the energy price dropped to nearly zero, to the minimal, then they turn the heat pump on. We're on the agile tariff to make best of this. So look how high it goes in the gaps in between. Working well so far. It's not for the faint-hearted, because you end up with a bunch of basically oil rig people in your garden. And as you can see, there is, albeit missing the ordnance and the duct boards and the uniforms, pretty much a good reenactment of Passchendaele. Fortunately, it was dry. The other thing about retrofit, obviously, is we can make things beautiful. It's come up in the conversations. No one wants a loan for a retrofit, but we can't fund 27 million houses any other way. So we ought to be looking at things that make people want to aspire to a retrofit. So this is, they still haven't got a radiator up here. They've done one full heating season and not needed it. The rest of the house had a retrofit to the same standards as in the previous slides a couple of years ago. So they wanted this on the top. And I think if we can make that kind of thing normalised as part of the offer, then we might be able to shift some more retrofit. Also trying some experiments in using UK grown timber because whilst the hydrogen lobby is trying to get us to go for alleged blue hydrogen, which only works if we've got CCS, actually a nice big tree that you've grown, cut down, reuse the timber carefully and then put it in a building where it'll stay for however many years the building stays up for is a better approach. We can also use the opportunity to do nicer things to our buildings. So this is an old set of weavers' cottages in the city centre. And now have, did have, unfortunately, until the tenant had to move because the landlord doubled the rent. But that ground floor is triple glazed and vacuum insulated panel doors with a sliding set in the front so that they can alter the downstairs event space accordingly. But also we then, you can, when you're looking at those bits of workspace, you can get away with some very, very small heat loads. We didn't do PHPP on this. We didn't have a budget for Passive House, but by careful detailing, we managed to get that whole place only heated by the losses of the people in it, the lighting, because the rest of it's reclaimed on an MVHR unit. How you pay for it? Obviously, the nearer you get to net zero, the higher the cost, and it's an exponential curve. Each half of the emissions you want to halve costs the same amount as the previous half. So paying for that means you've got a loan repayment that follows that curve. If the public sector was to step in and do PWLB level loans, albeit the ones pre the government sticking an extra % on them, then obviously you can make that loan cheaper. The problem with the emissions reductions and indeed therefore the bill reductions is that's a linear thing. So as you can see, there's a sweet spot somewhere around the 40 to 50% mark on current assumptions of retrofit where it pays for itself. But if we're going to get our entire housing stock to contribute appropriately to net zero and leave the renewable capacity for the bits that can't be retrofitted, then we should go to this one at the very least. This gets us to 70%. If we stick PV and battery, now I get the point that individual batteries may not be the most efficient, but they're the game in town for the moment because the business models are very nearly there. You can therefore massively increase your self-consumption, so you can reduce those bills. Obviously, the amount of saving is then slightly dented by the fact that you've got to pay for the PV and the battery. However, if we can get between 1,000 and 1,500 batteries federated, we can start to liberate a whole load of incomes that mean that sweet spot where the cost to the occupant or the cost to the bill payer, given the number of you from RPs there, starts to massively reduce. And the viability increases. You can get, basically the maths falls apart. You can get to net zero if you can get 6 kilowatts of PV on a roof on that fabric standard, just to bring it to a simple number. Now obviously currently retrofit costs way too high. So at the moment delivering the houses for Homes and Energy Systems, we're looking at 50 grand, which is an eye-watering sum of money this week. However, as PV has proved and as has every other major new innovation proved, if you get it out at scale and you get the chance to perfect it, those costs will reduce. And we're obviously not just being hopelessly optimistic, well, unless BEIS are too, because they've got a similar target of reducing the cost of retrofit by half over 10 years. If we can get that curve of cost reduction going, then as you can see with the different coloured lines there on loan repayments, on the terms, then we cross over the viability line at different points depending on what we're doing with the savings. So basically where the bars cross over the lines is the point at which it's zero net cost. So what we've got there is that if we've got public sector works borrowing and we've got the income from the PV, then we're going to be able to make this work. It's not going to work ever without that income that we can get from aggregating energy sales on this current spec. So for those people that said that those costs are too high, they're right by themselves, but we need to be looking a little bit more cannily at the other opportunities created. So if you're an RP with 2,500 PV installations in your stock already, you stick batteries alongside them, you've got your minimum participation volumes to join in the energy markets once you've found the virtual power plant operator to help you. The other thing that this does is that PV and batteries are a lot easier to scale up to the kinds of demands of zero carbon than retrofit, because retrofit, we don't have the workforce. So we've got to train them. We haven't really got the supply chain perfected. As you've just seen, the economics are not quite there yet. Whereas PV and storage, all we need is a couple of regulatory things to finish their journey through Elexon's corridors of power, and it'll start to work. And that market will become very, very busy very, very quickly. And we need players in this field that are on a multiple bottom line than just profit. But what that means is that if you can get that PV and storage income moving, then the early years, which is the green line where you dip into the red as you do a mass retrofit program, you can step straight up into making quite a lot of cash. And that will then enable you to then fund other parts of your process. All those people say, well, who's going to fund the assessments? Who's going to fund the unable to pay parts of your loan product? Where's that all coming from? The other part of this is that if you can deploy PV and storage faster, then that gives you a chance to make a dent in the beginning of the carbon reduction curve, because that green trajectory is the one that Tyndall are assuming we're going to do. The other thing, if we can make this work, is that we could actually eliminate fuel poverty in a decade. I realise that's going to make a whole load of people go, nah, mate, you've got no chance. But we've spent a while looking at the numbers, and we think this can work. It does, however, require quite a lot of action on quite a lot of fronts. And so I'm just going to quickly whiz through these, because obviously it's the first bit you wanted me to talk about, but I wanted to prove we can do this. Basically, there's a bunch of people want to go now. That's the green 2.5% at the bottom. And those people will be interested in a loan. They'll be interested in the product. They'll be prepared to let us take some risks. I know this because I've done 25 of them. And once we've got them moving, then a whole load of people, the early adopters on the Rogers curve, will then go, oh, okay, not that scary, maybe I'll do it. By the time we get to the mass market, a whole load of things will change. I'm not going to try and future cast 7 years, 8 years hence. So that means that if we can get all our ducks in a row now, using the people that want to go now, then we can build a program that then means we've got it perfected when we hit the less certain parts of the market. Parts of that mean we need to make sure our assessment processes work properly. At the moment, we're using RDSAP, which generates an EPC. It doesn't generate a viable model for your home unless you tweak the way the data is entered, or you alter the restrictions on what DEAs are allowed to put in. The thing with RDSAP, though, is it's built on the top of a SAP engine, and I've built a full SAP engine. It's what's lurking behind that, and it works. It enables you to be able to properly work out where the heat's going, and then work out where you're going to stop it going, so that you can then only deliver measures where they're going to work, not unless you've got a customer that wants it to look nice. But things like front doors, actually a passive house front door never ever pays for itself. They look nice, but don't put it in there because it's going to save you the carbon. However, underfloor and EWI are the big ones. And in fact, you don't need to go under the floor if you carry your EWI past the edge of the floor and you create a pocket of warm ground underneath if it's a ground bearing slab. We need to be monitoring our houses an awful lot better. How many of you have put measures into houses, and actually once the university that was monitoring it's potted off, you've got no idea what's going on? Actually, there's a lot of low-cost monitoring equipment about there. The one on the left was a design of mine for dealing with underfloors and only ventilating them when you want them. The one on the right is a very low-cost open energy monitor that just means that people know where the power's going. Smart meters are supposed to make that happen, but it's still a way to go. The other thing about the data is it then enables those doing the strategic planning to know what's going on. The geeks like me will spot a change in the patterns of indoor climate in a house that's already been retrofitted, and I'll be able to spot a problem before it becomes a costly one. Any of you doing maintenance know that the earlier you spot a problem, the cheaper the solution is. We can also then feed that data into other things. We need to make sure our software is doing a better job. We need to do much more with the open APIs that a lot of the more enlightened software providers do. That API is the thing that enables software to talk to other bits of software, because we need to make sure that stuff joins end to end, because there's not enough people like me to go around. Obviously, some people will say that's a good thing, but in terms of technical expertise, less so. We need to make sure that we can do an awful lot more with an awful lot fewer people while we grow them, as it were. We need to make sure that we specify in detail properly. Some of the research that Nick Heath did for the BRE, 70% reported more damp afters because they used the wrong product on the walls. We've tried to do some of this by creating a pattern book of details. That's retrofit.support if anyone wants a peek. It's got 1,200 unique users at the moment, despite not being updated for 5 years because it was part of a Green Deal Communities project. We're hoping to actually bring that up to speed. Contracting and guarantees. Many of you may well have tried to make that work and gone, oh, because you can't know everything before you start it. And I've just realised I'm 30 seconds over. Liam, do you want me to stop now or shall I just finish them quickly?
No, please do finish if you can begin wrapping it up. Thanks.
I can crack on. I'm nearly there. Obviously, Energy-Sprong has proved that you can do different contracting models, but actually, the excitement with them is not the offsite construction. The exciting bit is a performance guarantee for 30 years. That properly makes the contractor go, well, I won't just use mastic as a waterproof membrane. I'll actually do the job properly because then I don't have to come back. The additional revenues from PV then, just very quickly, you're talking about moving the power from when you want it, from when it arrives rather to when you want it. And there's some very approximate figures. They move every week, but you're looking at between 60 and 90 pounds per kilowatt hour of battery per year income if we can get it moving. It requires a fairly large scale response, but in effect, I think that puts the public sector and the social housing sector in a cracking position to do something about it. We need a finance vehicle that does the job, as I said, and I think that has to be public sector led because then its covenant can bring in that low cost finance. It will then be able to create offers based on those multiple bottom lines. If you can lend out enough to some able to pays and use a 0.25% margin on top of that to then fund your less able to pay and then be able to grant equity products to those people totally unable to pay. That's how you get out of your fuel poverty. We need to make it scalable. We need to do demonstrators everywhere to get started, but we then need to roll that out at scale. And then the big one is actually, where are we going to get a workforce from? We need hundreds and thousands of people. The big guys on that scaffolding are out of work theatre technicians that I'm just trying out to see if I can grow a workforce that way. Turning out quite handy so far, although past 2030 is getting in the way of that. And that's how you do it. You don't just think there's one magic bullet, you push on a whole load of multiple positions all at once. Thank you.
Thanks for that, Charlie. I thought it was really interesting, a lot of information for attendees to digest, and I'm sure they'll be looking forward to looking through everything after this. We do have one question that came in from Rob Ashby, and it was at the very beginning of your presentation in terms of that choice of the 0.2 watt meter squared. Is that right?
Mm-hmm. Watts per square meter, watts per degree Kelvin.
Got it. What was the thinking behind that, and why did you go for that?
As I said, it's working backwards from the modelling. So basically, if you want to get your energy performance down to the kinds of levels where the renewable capacity can do it. So it was based on the novel of the Rogers curve that we did. If I just, I'll just very quickly reshare that slide because it's worth just spending a bit of time on this. It's basically that slide there. That in order to get to that, the level of reduction we put in that was home insulation to 75% reduction in heat demand. If we did it at 50, we couldn't meet the budget. So the budget was on the other page, although it's actually not shown up in this slide. But John Broderick from the Tyndall Centre put a carbon budget calculator in here for us, and it said 75%. I'm doing some work with ENGIE on a zero carbon Rugeley proposition as part of the smart local energy systems, and we've redone the numbers with what's available in Rugeley, both in terms of rooftops, geothermal and wind, and we've ended up in the same place. A 75% reduction in heat demand on average looks like it enables us to cross the bridge. So therefore, once that's your target, then 0.2 on the walls is the biggest saving, and it just gives you that extra. So if you're going up the scaffolding and you're going to do 90 mil of EPS, don't on one of those. Obviously, use something vapor permeable, but go the extra thickness so that you can then not have to come back later.
No, that's great. And then maybe one more question before we move on. You mentioned ventilation as the forgotten aspect of retrofit,
Mm-hmm.
and I was wondering, why do you think that is? Why is it important? And has the pandemic and coronavirus changed that? And there's more importance now on air quality, amongst other things, in terms of sort of preventing overheating, for example, and things like that.
So the reason why you want the ventilation is because it's one of the other. So if you look at the trajectories for mold in a property, One of them is water that got in from the outside and found its way to the inside. And not actually as anywhere near as often as people think it is, but if you're within a foot of the ground, then there is the possibility of some water getting in from the ground slab and carrying its way up. But by far and away, most of the moisture in a house is coming from condensation on the walls from the internal occupants. So even though you've insulated it, you've done it properly, you've dealt with all the cold bridges, you're still going to get some places where you need to keep the air moving. But also the other problem is if you've done it airtight, which you need to be able to keep control of how much heat you give to the pigeons sitting on the roof on that one air leak you've got, or imagining the thermal image when the wind blows and there's a big red smudge to the downwind side of your house, you've got to then make sure that the indoor air quality is appropriate. And it's been proved to do quite a lot of good to the occupants. And obviously one of the other things that we're looking at out of this, for the punters that bid into my Homes and Energy Systems project, 120 of them, we were somewhat stunned that 80 of the applicants had health issues that were basically to do with the state of the house. So you're right, the coronavirus has merely proved the point, but it was a point that needed making anyway. What would be interesting is how many people's lungs have been already damaged before the virus happened as a result of atrocious air quality. There's already stuff coming out about nanoparticulates from diesels possibly giving you a worse outcome. I think there's going to be more to be found.
Well, no, I think that's a very good point in terms of coronavirus, underlining points that had been tried to be underlined for many years now. Well, thank you for that. We hope you can stay for the group discussion at the end. I'm sure there's many points you raised in that presentation about workforce development, that sort of place-based regeneration and retrofit's role in that across tenure as well, which you touched upon. I'd love to get your thoughts on that. But for now, thank you for that. And I'd like to bring in Patrick Berry for his presentation. I'll ask Patrick to start his video and I'll be looking after Patrick's presentation as well. So I'll start sharing my screen once we have Patrick there. Thanks, Patrick.
Okay. Okay, thanks for that, Liam. That's a kind of nice segue from Charlie about solar PV and battery systems and the large potential that they have. We have a pilot project which we are doing in East Lancashire and been asked to speak about that. We're about 10 months into that, but it's producing some interesting results. I'd like to just take you through our approach to that and how we got there. If you go to the next slide, Liam. So just by way of context, Together Housing, we've got about 37,000 properties across Lancashire and Yorkshire. And we took advantage of the feed-in tariff when it was available. And we've got just under 5 megawatts of fit registered systems on about 750 properties. Clearly the fit tariff had the desired effect on the market, which enabled the feed-in tariff to be withdrawn. Obviously that leaves us with choices about how we go forward and how we can make the most of solar. So we feel that solar and solar PV and batteries has a large role to play as part of our decarbonisation strategy. What we did see from systems that don't have batteries, which whilst they made a good income from fit, only about 30% of the power generated is actually used by the tenants. And so the benefits are severely restricted. So we wanted to find another model which would allow us to invest in and pay for solar at a much larger scale across our stock as part of a wider plan, because paying for these things is always the key. And so we're looking to test a fundable, sustainable model that could operate in a post-fit environment for social housing and allow the sector, as I think Charlie suggested, the sector has a real potential role to be market makers here. The scale at which we can act and invest will allow prices to fall if done in the right way and have a major impact on how that can be picked up by the wider market as a whole. What we're trying, would hope to do, if we can make this work, as again Charlie has talked about, is to create the biggest virtual power plant we are able to do across our stock, which allows us both to generate income but also to and to recycle that cash back into further investment, but to play our part in the decarbonising of the grid as it goes forward. Next slide, please, Liam. So the case for that obviously is driven by lots of pressure for net zero carbon. Most of our stock is stock transfers from local authorities, all of whom have declared carbon emergencies, and they're looking to us as large social housing providers to help lead the way on how we decarbonise our stock. For our new build, we've got the Future Home Standard coming. We're looking to do perhaps more than the government suggested there. So what role does solar PV and battery play in that? We do foresee a time in the future where people like Homes England will be much more interested in what we're doing about carbon and really apply that in a much stricter way. There may well be carbon pricing downstream, which will affect both consumers and large organisations. But we do see that there is real market opportunity for early adopters of this technology at scale, and we're trying to create a model in which we can do that. So we have identified an approach which that we then took forward as a project to be co-funded by ERDF through the low carbon economy stream, and that was successful. And during 2019, we installed those systems. So this is an opportunity to do something really very interesting that could be a much wider benefit across the sector. Next slide, please, Liam. So the project is 250 sites in East Lancashire, which is not the sunshine capital of the north, so it's quite a test. And the idea is to install the systems and collect enormous amounts of data about how those systems operate. Again, something Charlie referred to, which we will put into a data warehouse, and that allows us to cut and slice the data in lots of different ways to understand what's happening with systems and how they interact with consumers and what market opportunities might be created from that, and to try and test that in a variety of different operating models. What we're trying to do is demonstrate a proof of concept here as an investable model for social housing, and to widely disseminate the results of that across the sector and to anyone who's interested, including access to the data where appropriate, with the aim of creating a transferable model. Next slide, Liam. So again, I'm going to keep referring back to Charlie because quite a few of the points he made were a nice segue into what we're doing here. So we try to operate on a triple bottom line objective, where how much it costs our tenants to live in our stock is increasingly key, as we've seen the cost of living rise much quickly than, say, benefits and low incomes. And so long-term affordability of our stock is key. How much it costs to live in those properties from an energy perspective is a major outgoing, and so it's a major factor in affordability. Anything we can do to reduce that, both through our retrofit and through the production of renewable power in this case, we think is particularly important. 90% of our carbon impact comes through our stock, based on the energy efficiency of that stock and the heating systems that are in it. And so we're looking to have a direct impact on that. And we're looking to create something where there is potential for a return on investment, though our ambitions are relatively low in that respect and will be recycled in any event. But we're looking for something which is sustainable. The more there is a chance for potential return, the cheaper it can be for the tenants in the properties. What's interesting about this approach, as a kind of segue for social housing into the energy sector and generation of cash through the energy sector, is that the assets here are tied to our core assets. So these are part of our properties and our houses across the piece. And obviously where we focus all our efforts. This is not something completely separate as a new business. So it allows us to add value to what we're already doing in a helpful way. And what we'd like to see going forward is that the provision of renewable heat and power become much more part of a social housing service norm, where we can deliver direct benefits to the tenants. Next slide, please, Lynn. So solar PV and battery storage systems we've installed. The model which underpins them aims to harness multiple revenue streams. And underpinning that is you have to be able to sell all the commodity somewhere. The best place to try and sell that is to the tenant. And we're talking about doing that at market discounted rates. So there are real measurable benefits to the tenant. The more successful the other bits, the cheaper that rate can be. There's also the opportunity to sell to the grid, both in terms of export. There are also opportunities to do slightly more innovative things with that export, and touch on that later. And long term, we'd hope to be able to sell export energy to other tenants with peer-to-peer arrangements. That is regulatory. So the regulations prevent that at the moment, but there are conversations going off with Ofgem. And I think the ability to sell peer-to-peer is key to local energy projects of all types. But a key point, again, Charlie referred to this, is the ability to sweat these solar assets by working with grid flexibility services and demand-side response markets, which would be able to generate long-term revenues. The use of batteries and demand-side shifting is a key part of the national strategy for the grid, and we can play a key part in that, where there's mutual benefit to be gained, but you need to have scale to be able to do that, hence the creation of a large virtual power plant where we can. Next slide, please. So the basic model for the project is this, where we have a solar installation connected to the hybrid inverter and battery systems, and where the tenant is able to use the power directly, it goes, well, first of all, the system itself operates dynamically. So I think many people think that when a system operates, just the spare energy goes into the battery and you keep it there till later. In order for to maximize the amount of power used on site, the systems operate dynamically, so that if all the solar power can be used within the property at the time it's generated, then that's fine. If there is power that can't be used, that then goes into the batteries. But if there's a spike in demand in the property, so someone puts the electric shower on, for example, then and the solar power can't meet that demand, then the batteries will kick in on top of the solar power. And if the grid power is needed on top of that, it will also kick in at the same time. And when that demand spike falls, it will return to various forms of the different state. So the battery charges and discharges throughout the day dependent on the demands in the property. And so that allows you to maximize the solar power that is used on site. And when the solar power stops generating, as you go into the evening, the batteries are there to be able to help cover demand over the evening period and across the night. The data that's been collected by the systems allows us to work with aggregators, which would be the gateway to demand-side flexibility markets. That's the balancing mechanism, the capacity markets, and fast frequency response markets, which the systems are capable of working with. And again, APIs can be created between the platform and the aggregators. We're also working with a couple of energy suppliers, because for us, they need to be part of the mix about how we operate the systems and manage billing systems. We're not particularly keen to have a separate billing system. We manage ourselves, and we'd also like tenants to get a single bill wherever possible. So we're looking at operating models with Octopus Energy, who are very innovative and active in the market, but also Utilita, who tend to be the go-to provider for pay-as-you-go. Both interested in how they would engage with this sort of technology, which I think is encouraging. And what we're about to do is look at the practical application of time of use tariffs, agile tariffs. In Octopus's case, where there are 48 price points every day, and they change daily, though the patterns are broadly the same. And with Utilita, a kind of economy 10 tariff. The idea is there that the systems will be optimized on behalf of the tenant to minimize the costs of grid power, but also maximize the use of the batteries and the solar power. But ultimately revenue deriving back to ourselves. The peer-to-peer, as shown on that chart, is something we'd hope to see further downstream. Next slide, please. So this is just a from the portal which operates the solar systems, just to give you an example of what I've just described. So the blue on the graph is the solar output throughout the day. You can see there's some cloudy parts of that solar output. The green is the demand in the property, which spikes at different times in the day. And the grey is the battery. And below the line, it's charging. And above the line, it's discharging. So you can see how how that system operates, where for lots of the parts during the day, the solar output is meeting the localized demand in the property. But where the property spikes, then the battery will kick in to help cover that. And as we go into the evening, then the battery covers the demand that's there. So most of the time during that day, that property is shown to be off-grid. Next slide, please. What we are also trying within the pilot is, because if you've got 17,000 properties, and when we first did the feed-in tariff, there was a very strict approach to the southerly facing aspect of the properties as the targets for the installation. If we're going to roll this out at scale and do it across a much broader group of properties, then we have to see how the systems perform on different orientations. So as you see on there, we've got south, southeast, southwest, east-west, where we've actually done dual aspect orientations, just east and just west. And whilst the southerly aspect, it still performs the best out of the group, we have seen that it is possible for the other orientations to work effectively, albeit they have a different shape of generation curve, but that can work to your advantage. So an east-west orientation has a slightly smoother curve, which allows more of the generated power to be used on site. Obviously, an easterly facing orientation allows more power to be used in the morning where that's appropriate, and westerly more in the evening. But we have found that useful, and we can slice and dice that data across the different house types as well. Next slide. What we have found across the different types of properties, and we've deliberately done it across a wide variation of properties in Sunny, Cole and Nelson, is that the systems generally work better on large properties with larger systems and larger occupancies. So here's an example in summertime of our larger properties grouped together, and you can see on that a large amount of solar in green is consumed, but we are still exporting fairly sizable chunks at the peak of the solar output around midday, but we're also still importing from the grid, particularly in the morning and the evening. But there's a very sizable contribution from the solar to the overall household consumption. Next slide, Lynn, please. Conversely, we have done quite a number of bungalows and single-person and two-person occupancy bungalows, where by and large demand is very low. And so it's good for the tenant in that virtually all their consumption is met by the solar system during the summer, but we're still exporting large proportions of the generated power. And really the best input for the model is when more of the power is consumed on site. So it either points to the fact that the system's too big for those properties because we're generating too much, or we have to find better ways of realizing value for the exported power. Next slide. We're also modelling, because obviously we are looking at removing gas from our properties over time. An air source heat pump for houses is a preferred route. So we're just looking at all the properties we did in the pilot, as most of our properties have a gas heating system. If we were to use an air source heat pump or electric heat, obviously that should increase the levels of demand across the properties. So the bottom axis there are the number of bedrooms and the number of panels on different properties, which shows that we could realise a substantive increase in the power consumed on site by combining the air source heat pump with the solar and batteries. That's a modelled set of data. We are looking to actively pilot the introduction of air source heat pumps with the option to optimise how they work together and to get some real data to back that up. Next slide, please. So we've had the systems on for about 10 months at the moment, and we have enough data to really start building and testing versions of the financial model from a social housing investment perspective. There are various forms of private investment there at the moment. They tend not to bring great value back to the tenants, in my view, and certainly not to you as the host of the building upon which the assets might be stored. So, as I mentioned earlier, we're looking at different kinds of operational models with the energy providers, including kind of fixed price models, where everything behind that price is operated by us or by our preferred operator to maximise and optimise the systems. We're testing data also with aggregator to see what the revenue levels will be from the demand side flexibility markets. And we're also talking to blockchain intermediaries, which would allow us to realise greater value for our export in the marketplace. As I mentioned then, we've got air source heat pumps that we want to practically pilot and install alongside smart thermostat arrangements, which again will just provide greater control and more data about the property as we go forward. And we produce, because this is an ERDF project, we are very much committed to trying to disseminate information and share data about the project to allow others to think about how they might approach the same issues and use the solar PV and battery approach. And anyone who's interested can certainly get in touch with us to do that. We think there are great legs in this. If we can make the kind of approach we have to this is if we can make this work now in today's market conditions, that's only going to get better. The price of the capital will fall. We believe the revenues will rise, and it will allow us to deliver much greater benefits to our tenants in the longer term, whilst also obviously benefiting from the carbon reduction. Next slide. So anyone who's interested in finding more about the project in more detail can contact me there. We do hope to produce a series of webinars ourselves in the coming months where we can go into much more detail and obviously bring the different protagonists to the table about their roles in the projects and their interest in the projects going forward, which we feel will be of use to other social housing bodies. Thank you very much.
Thanks for that, Patrick. Great case study there, and good example of the good work that can come out of a little bit of upfront funding as well. We do have one question that's coming from Kenton Barker. So how does the RTB, that to me is right to buy, I'm not too sure if that's right, of the properties where these are installed affect the use of the batteries and the solar?
Yes, we haven't confronted that one directly yet, but it's obviously one that's real. I mean, what we've done with our feed-in tariff is that effectively we had a kind of roof lease on those, and the roof lease transferred to the occupants, which allowed us to continue to maintain and operate the systems at our cost, but obviously to receive the feed-in tariff. And we're looking to replicate a similar system here. If there was a right to buy, we would put in place some form of roof lease or license with the tenant, which would allow them to keep the systems to benefit from the cheaper electricity, but for us to be able to continue to trade them in aggregation markets, etc.
No, that's good. And I think that fits in with what I was mentioning before to Charlie about potential point of discussion when we bring everyone together, was hitting that cross tenure work and making sure all retrofits in the neighbourhood are completed and everything's coordinated and joined up in that way. I'll leave that there for now because I'm conscious of time, and we'll bring you back in at the end, Patrick, for that group discussion. So finally, we have Wes McGeaney at 13, and Wes will be going through another case study for our audience. Now, I am again sharing my screen, so I'll do that now. Thanks.
Thanks, Liam. Just want to say thanks to Charlie for the pretty good overview on retrofits and how to make it affordable, and obviously Nigel will come up with the PV systems. A little bit of background. My name's Wes McGeaney. I'm the Renewables Manager at 13. We currently have just under 34,000 properties in the northeast of England, predominantly the Tees Valley area. Like I said, I'm the Renewables Manager, a background in project management from decent homes, etc. Next slide, please. Liam. Cheers, thank you. So what we're going to go to is what's actually sat in our portfolio at the moment. We currently have 900 PV systems which produce electricity, as Nigel picked up on, so they're for the customers' benefits. We have 400 air source heat pumps within our stock, which, once again, Nigel mentioned, if you put them with PV systems, they become almost cost neutral. We have 350 solar thermal systems out there, and we have 10 ground source heat pumps fitted as well. Next slide, please, Liam. So this is what we delivered last year. Obviously, just before COVID hit us, we delivered 100 air source heat pump installations. These were full installations with a wet system. The cost approximately was 725,000 for these systems. These systems were to combat fuel poverty for our customers. The ratio of an air source heat pump is basically 3.5 to 1. So in English, that means for every 1 unit of electricity you burn, you get 3.5 units of heat. We tapped into the Warm Home Fund, £170,000 funding, and we did something called assignment of rights, which allows us to sell the 7-year Renewable Heat Incentive Fund, and we tapped into a £300,000 on this. What I'm trying to get across here is we can make it almost comparable to gas. So gas installation is roughly 3,200 plus 20% VAT. So the air source heat pump will come out roughly the same, but it's only a 5% VAT under HMRC. Next slide, please, Liam. So this is one of the schemes we did. 16 air source heat pumps in Thornaby, which is Stockton based. It was a removal of economy 7 night storage with hot water cylinder as well. The benefits are obviously the customers. There's benefits around health and well-being for the customers with a constant heat source, ambient temperature, no emissions. The carbon impact, obviously, we don't know what impact SAP 10 is going to have when it comes out. The available funding streams there, so we can make it almost comparable, like I say, to a gas installation. Let me just. So next slide, please, Liam. So this is one of the big things. What we do with our air source heat pumps, we try to minimize visual impact so it fits into the environment. So you can see 2 examples there. One there, we've wrapped it in an anthracite wrap, and the other one we've done a brick slip wrap. Started doing these a number of years ago. Goes down really well with the customer base, takes the eye off the external pump, so it mitigates the visual impact of the pumps. It's a good one as well when we go through tenant consultation. It seems to win a lot of people over because a lot of people don't like the look of an air source heat pump on the front or the rear of the property. Can you, next slide, please, Liam? So these are some of the funding streams out there. Obviously, I've mentioned the renewable heat incentive. It's a 7-year fund paid by Ofgem. For solar thermal as well, you can get the same fund. We were recognised as the first company with the assignment of rights in England. We did it back in 2018 under a different form of partnership agreement under Heat Right, which is a company in London. Helps with the capital upfront cost or the capex. So obviously an air source will cost between £7,000 and £8,000 to install. So if you can sell it up front, obviously it mitigates the costs and it makes it more affordable. There's a lot of funds out there from the Warm Home Fund, which is another National Power Grid Fund. We've taken almost £500,000 over the past 3 years from that. There's also Northern Gas Networks out there where you can get gas vouchers. There's the Green Homes Grant, which is the government fund that was released. So homeowners can get 5,000 to 10,000. And there's also eco funding out there. I take on board what was said in the first presentation. Obviously, the financial impact of retrofits and full house fabric first. This is what 13 look at. So what we do is we approach the fabric first, and then we put in renewable technology such as air source. There's a thing called the SunAmp thermal battery. We do electric battery storage. So we try to encompass all the different technologies together to reduce it to that footprint per metre squared. Next slide, please, Liam. So like, it all looks hunky-dory, you know, I mean, in English, because I don't want to be too technical. There's problems out there and there's barriers. Permitted development is pretty easy to do. You don't need any planning permission. But what I found in my background and experience is people out there don't know the tech. They don't know what we're fitting. And we sometimes hit barriers from local authorities, planners. The DNO with the grid is saturated. So you have barriers with the DNO, and these are starting to break down. You also, whenever you do this type of technology, you've got to do your secondary measures, such as loft top-ups, your triple glazing, you've got to do your underfloor, your cavity wall. And then another big stumble and block is your utility metering, changing from economy 700 GDPR. For customer base like us, it's very difficult because the utility companies can only talk to the individual customers. So there's a big consultation that has to be carried out there. Obviously with these as well is the environmental impact, which is carbon free. We're looking at, you know, getting it down to net zero. Next slide, please, Liam. Big thing, big massive thing is our customer behaviours. It's all right putting all the kit in from PV, solar thermal, ground source, everything. What you need behind that is a big consultation education package. Also, you need a full monitoring package. So you keep up to date. I mean, the ones we fit on air source heat pumps, they do have electric metering built in. You can also fit in a meter monitoring service package, which is a basic portal, very similar to what Nigel showed us and Charlie. So you can actually see the systems working. You can
sorry, it's Nigel. Can I just interrupt a sec? Because I think you're referring to me when you mean Patrick.
Oh, sorry. Sorry, Nigel. Oh, sorry, I mean Patrick. Sorry, I do apologise.
Yeah, just let people know. Sorry, right.
Yeah, sorry about that. Sorry, Patrick. So we do, there's a big education package there. So what we can do is we can educate our customers, and what we tend to do with this is on demographics. So we do simplified instructions, crib sheets, etc. Highly important is our customer behaviours, because the tech won't work unless you've got that educational package behind you. Next slide, please, Liam. And there's my contact details. Obviously, we want to benchmark with as many people as possible. So like I said, with the two front presentations, which was really good. If anybody needs to get in touch with me, feel free. Thank you, Liam.
Thanks for that, Wes. And at this moment, I'll invite our other speakers to come back in. While they're doing that, a question from Stephanie for you, Wes. Do you know roughly how the AOR compared to drawing down? I'm assuming the renewable heat incentive, drawing that down over the 7-year period. How the AOR affects that? The acknowledgement of receipt, maybe.
It doesn't. What we've got an agreement with Heat, right? You get between 75 and 80% of the actual value. So your 7-year RHI is index linked, so it's got a growth of maybe 2-3%. But what you've got to do, you've got to compare the pound now against the next 7 years. Mm-hmm. So, for example, if your RHI over 7 years is worth £4,000, AOR will pay between 3 and 3,200 as a lump sum capital upfront cost. So if your air source heat pump costs 7,000 to fit, it comes in at roughly £4,000. Mm-hmm. So that's how it works. There's a few other people who do it. CES does it in the Northeast, which is Northern Gas Networks subsidiary. There's a few people out there who actually do it. We've actually sold over £500,000 worth of renewable heat incentive.
Right, no, that's great. Thank you for that. Charlie, did you obviously come at this work in a different tenure? Did you have any questions for our speakers from the NHC membership here?
Well, no, actually, my primary point was that I've been being told by many people that what Patrick's doing I can't do. So I was very chuffed that actually he's doing a model with his EIDF that says that we can start to get incomes from disaggregated storage. And it's quite, I think we might have to have some more conversations about this, because it's nice to finally find somebody going, yes, you can do it, and yes, this is worth doing. Because I've been feeling a bit like Johnny No Mates for a bit. So thanks for that, Patrick. The other point I did want to make, though, is that what has come out of the work we're looking at is if we can reduce the energy demand down low enough, the heat pump prices drop to the floor, because you can start to get to the really small ones. I think what we'll have to get Dave Kemp back on this at some point later, because he's doing shared loop ground source heat pumps as part of his work, and I'm really interested to see whether that means that we could maybe get heat demand around a lot lower, because there'll be a sort of communal heat pump, which then also starts to play into maybe better community development and better buy-in from communities about how we make all of this zero carbon journey work, which then plays into what Wes was just saying, that you've got to make sure that people understand why it's happening and don't just go, well, what, you haven't done this to me before, which obviously starts to make life a bit difficult.
No, that was the point that I was going to raise, Charlie. And just before I do, just to our attendees, if you'd like to put any questions, again, please use the Q&A function in the chat box. We've got some time left for questions and discussion. We'll not drag it out if there aren't any questions, but please do take this opportunity to engage. So on that tenant behaviour engagement and education with residents, I didn't know whether, Patrick, did you want to begin and just discuss a little bit about that with the work that you've been doing?
I mean, in getting people engaged with this, it was the question we got asked most of all was, is it free? And B, will it save me money? And if we could answer yes to those two, then people participated. What we have found, however, is that a fairly substantial proportion of those people are willing to engage in, have really fostered an interest in the whole renewable technology stuff. And they are keen to participate in experiments with us using time of use tariffs, and for us to optimize their systems on their behalf. So I think, what we are able to do from the systems is that every quarter we send them a full breakdown of how they've used the solar power, what proportion of that power has contributed to their overall consumption, etc. And we find that people are actually reading this data and calling us up or asking questions or understanding it. And I think you have to have that constant supply of information to engage people in this whole change.
No, that's good. Wes, does that chime with your experiences?
Yeah, it does. Obviously, we have something similar, Patrick. We have our solar PV array under fit, and we have quite a lot of battery storage out there. So it's all about, for me, it's all about education. I've been to many a forum where people have actually pulled air source heat pumps out because customer understanding wasn't there. And so what we do is we really try to bring the customers up to spec. But I actually saw something on Net Zero the other week, and I think it was, it might have been the E.ON managing director. He said, try to keep the information when you pass it as simple as possible with no jargon, which really hit home, because that's what we try to do as an organisation. Change the dialogue, make it simple, make the people understand what you're doing. And it goes a long way, I've got to be honest.
No,
it's interesting that the other thing that I've found in polling probably a wider demographic, I guess, because most of my work has been with owner occupiers. Well, no, it's half and half actually. Is that there's the market segmentation curve I showed at the beginning. That there's a lot of people really wanting to do something and seeing their own home as being a place where they can do something, and therefore being quite receptive to a wider range of changes. One of the other ones that really sticks out from one of the ones we did a few years ago was somebody who had early onset arthritis. We sorted out her heating, dried her home out. Her symptoms have abated quite considerably. She is probably one of the strongest ambassadors for what we're up to of all the houses I've done. I think your point about people saving money is definitely a good one, but I don't think we should underestimate targeting those houses where people's health is being adversely affected by either their inability to heat it properly or deficiencies in the fabric of that property, that we could use this as an opportunity to overcome.
No, I think that's a very good point made. We've got a question from Craig here. Obviously, one of the main issues that people find is committing to a certain technology pathway or a certain brand or manufacturer. Could our speakers just talk a little bit about, from a PV perspective, and battery storage? So Patrick, maybe you could lead on this. Who are you working with? What sort of work went into deciding what was the best for your organisation? And Patrick, while I've got you as well, there was another question regarding return on investment for the project. Are you close to that? Are you able to share that with us, where we might be with return on investment?
Yeah, I can do that. Just talk about the technologies first. So when we went to market on this, we had a good response. Lots of the responses were from installers who were piecing together various bits of kit, who said they could meet what our specification was, because we wanted this dynamic relationship between the kit and the user, which I described. Actually, most of the systems couldn't do that, and we needed the batteries to output a usable kind of grid level, so grid replacement back into the system. So we're working with a company called Prime Hybrid Energy. They have a vertically integrated system, so they developed all the bits together. But having said that, going forward, we probably think it's the software itself that manages the systems and the portal that becomes the most important, because the technology will change. So even the time since we've put the systems in, battery prices have fallen quite a lot. You've probably taken the best part of £600 or £700 off battery prices in that period. Solar prices have already fallen a lot, and we expect the technology to change very quickly as we go forward, and we have to ride that curve really. So it's not about picking. What we have is an overall technology, which is solar PV and batteries, and an operating system and methodology. But the whole point is that we can ride the benefits of technological change as we go forward. Otherwise, we're going to get stuck somewhere we don't want to be. In terms of the return on investment, we currently haven't factored in anything from the demand side flexibility. If you took the figures that Charlie mentioned, between £60 and £90 per kilowatt peak, we'll be making a return probably somewhere between 3 and 5% IRR. At the moment, we're just trying to get some data on that from various intermediaries. I think I showed Enel in there, which is one of the world's biggest aggregators. And they were slightly cautious because they've been just working with Ofgem on the launch of domestic flexibility markets and the scales at which they can operate. So I haven't put those in. At the moment, we can get to break even. And with this additional revenue, both from demand-side flexibility markets and an increased level of export revenue, that should get us to where we want to be. And I've got a budget in next year's delivery to put the first 500 of these systems in a full operational mode. Certainly that's the plan. So between now and then, I have to confirm the business case and get that through our board. But that's where we are at the moment. So it's looking encouraging. It's not completely straightforward. If it was really straightforward, everyone would have done it by now. So you have to be looking for innovation in the way in which we put these things together. And the other thing I would be key to mention is the relationship with the tenant in terms of buying that energy and how that fits with the tenancy agreement. Now it fits with our relationship with the grid energy supplier. So there are other complexities in the model other than just the data, which we're trying to piece together, and we're happy to share our work with those who are interested.
No, that's great, and I'm sure we'd be happy to help with that dissemination. Do our other speakers have any comments on that at all?
I can add something on. We've carried out a procurement on our air source, for example. Have the same platform system with them. We only use actually two. We use a Mitsubishi and a Daikin. So they have a platform web system where we can monitor. You can actually do remote servicing on a Mitsubishi one that they're trying to push forward. So before you send an operative out, we get a 20-year whole life cost against that, against your combination boiler, condensing boiler of 15. So once you put them figures in, I'm sure Patrick will be interested in that. Once you put the figures in, it actually makes sense to pull gas out. And once the grid's electrified, your PV array and that, and we are going with something called the Sunamp thermal battery. So it helps when Charlie was saying, and Patrick was saying about the grid, you're not using electricity, you can charge this battery up during the day, 7 kilowatt heat battery, which gives you 150 litres of hot water. Because I've noticed nobody's mentioned hot water demand will never fall off. This is one of the things we've looked at. So yes, you can turn your home into a super efficient home. Doesn't need any heat. Hot water is always going to be there. People always need hot water. So we're actually looking at alternatives, say with a PV array, a thermal store, water, whatever, with a heavy interface unit, just a heat water during the day. So that's one of the pilots we're running. Well, I say a pilot, we've actually got them out there now. So it's.
Yeah, well, just from up, our models will work better. This is why I want to try the air source heat pump, because at the moment, of course, we don't have any tanks in our properties because they're all on the gas combi boiler. But if we can redirect some of the exported energy into heating hot water, then everybody benefits from that process.
I've spent quite a while modelling this. I'm obviously behind you guys in actual deployment, but I spent an awful lot of time on the spreadsheets on this. And where I got to was that if you've got a large, so above G83 qualifying PV array, but if you've got a battery, you can get away with it. You can then charge that battery on off-peak power, because that heat pump picture I showed you earlier was actually my own house, because I always try stuff on mine first before going, yeah, you want one of these, mate. The Octopus Agile tariff, because it's the only game in town this week, but I assume, judging by the way they're doing, other people will join the fray soon. You're looking at 4 or 5p at 2:30, 3 o'clock in the morning. And actually, if you can use, so I think it's not net, whilst the Sunamp batteries are quite cheap and I can see the attraction of them, it seems to me that if we can get the volumes of trade up and Sir Patrick can actually get to those other bits of the market he alluded to, it's going to be a toss-up. Because if you're able to charge a battery at 5p, then actually charging your water tank, if you had one, at that kind of rate means that you might make more money out of selling that power on the market, where even Octopus's own smart export guarantee tariff is 5.5p. Their Agile one, they reckon, will go up to 9. So there's some fun modelling to do between the different bits, and I suspect that all of the business cases are fluid as different incomes become available and different costs start to realise themselves. It looks to me like batteries are reducing costs, but I think the other place we need to keep an eye out as providers where you've got single landlords over reasonable quantities of stock is that individual batteries, from all the scientists I keep talking to, are not the most resource efficient way forward. We should be looking at the stuff in containers. And enough of the housing estates that are in social housing control have got what me with my urban design hat on call spaces left over after planning, it would be a doddle to stick a battery on the end of one of them, supply that power back into the homes around you. We've just got to work out the business models so that you can then make sure people benefit and see the reason to have them.
Wes, I could just add something of interest, will be of interest to you. I have another ERDF project, which is about to start on site, which is a new build site. We will have ground source heat pumps as the heating mechanism, but centralized battery storage and a full roof tile rather than solar panel on the roofs, subject to ERDF funding, which will do exactly those things. And we hope to optimize those systems exactly as you said, by bringing in cheap power to charge the batteries, particularly in winter, of course, and to optimize the systems both for general consumption in the properties as well as the heating systems. And we're working with Electricity Northwest on how that's configured at the same time. And when I talked about optimizing the systems on the current solar PV and battery installations, that with the time of use tariffs, that doesn't, particularly in winter, mean charging the batteries with the off-peak rates, so we can maximize the use of those for the tenant and minimize, because with the time of use tariff, you've got a range from 4 or 5p to 30p between 4 and 7. So making sure you control those costs and control that demand during those periods becomes paramount. And that's what we're looking to. You can't expect the tenant to be looking at the price of every half hour. So you have to optimize those systems to make it work.
I can add to Charlie's there, Charlie. I know you were based in Redcar, aren't you, Charlie?
Me? No, I'm Manchester.
Manchester. I can actually say we've got a estate there with maybe 250 PV on within a square mile radius. And I've actually been looking at the battery storage on a container and then putting the multi-grid into effect. Exactly as what you're talking about there. And the Northern Power Grid, we need to discuss some things like this with Northern Power Grid, which is our DNO provider. But we are really keen on the multi-grid effect and having basically a district electricity supply that we can buy and sell. And like you say, it's exchanging the way you export, you're selling it. It's got to be fluid. Totally agree. But we're well on the way. I think we're one of the Northeast leaders in that. Patrick, we do have systems out there with PV and with air source heat pumps and with solar thermal working together. A tenant's paying. I have 60 square meter bungalows with an EPC of a day, and the tenants are paying less than £450 per year for the full utility package. I've got one that's paying, I think the heat demand and the water demand's about £180. We've got a 3-bedroom house innovation where she's paying £600 with 2 small children. All the systems working together. And I use my own house. I think I pay about £90 a month for dual fuel. I use my own house as a template, just to see how much we can drive the costs. So with a PV and air source, I think you can drive the cost down about 35%, which is really quite good.
Yeah, one of the things I wanted to raise following on from that, Wes, is one of the problems we face, particularly around the peer-to-peer, but also it would apply to centralized battery storage potentially, is as soon as you start to move things across the network, then they want to slam a lot of charges on you, which prohibit that from being a sensible economic thing to do. And it might be local energy production in this way can't work unless there's something done about how we move electricity in local areas. And I think there's perhaps a role for the NHC in helping us to lobby on behalf of the sector to try and challenge some of those things with the DNOs and the grid.
But it's the barriers we face. I think I mentioned the barriers in the presentation. There's an awful lot of barriers there from our location for people. One of the big ones I find is acoustics. When you fit an air source, it falls under the same legislation as an aircon unit. I've actually carried out acoustic reports. And would you believe a gas boiler kicks out at 50 decibel when it kicks in a house, right? And I have got a company do one for me. An air source is gear driven, basically. So it's, it kicks in at maybe 22 decibels externally when it's about -1, shall we say. And I've actually come head to head with local authorities about this, saying you're putting a barrier in my way. I'm fitting these air source on our land. They only kick in when it's cold. So the tenants, if the windows are shut, it's external. Go on, Charlie. You've come across it.
Well, Dave Kemp is struggling on the rest of the project that we're part of in Manchester with this. The planners have just said, no, mate, you can't put those heat pumps on. You can't have planning for them because they're above the noise threshold. To be fair to the planners, because I've come across this trying to do a new build housing scheme in Lye down in Stourbridge next to a railway station in the middle of an old industrial estate. The problem is not the planners, it's the two different British standards to do with noise that are the problem. And that what happens is if somebody wants to sue, then they can use one British standard, but the way you assess it is on another one. And it then means that there's a gap in the middle you just cannot comply with, because it has to comply with, I've forgotten the actual precise detail, but it's something to do with that you can't go more than a certain amount above the background noise load, which when everything is shut is near zero. So like whisper, and therefore if you whisper on top of the whisper, all of a sudden you've come a cropper. So if you've got a resident who doesn't like air source heat pumps because they're one of them, and well, let's face it, we've all encountered them, they are allowed to kick off post-installation and have it removed because of this. So I think actually what comes about here is maybe Northern Housing Consortium talking to all the other people who's had these problems and make this an ask to government to actually allow the BS to get revisited, or to produce some framing guidance around it that you can use as your precedent, so that the planners are then able to let you off. Because I don't think there's any lack of appetite in planning departments to see it happen, but the environmental health officers have got their arms up the backs.
Very good point, Charlie. And if it's all right, I'll make that the final point. I'm conscious of time, and I think it's. Can
I just answer Rob's question?
Oh yeah, go. Oh, sorry. Yes, go on then, Charlie. Final point here. So Charlie's being asked, as part of his presentation, there was a re-elevation of a terraced house, and he was advised, if you're thinking about EPS for a wall like this, don't. Charlie, could you expand on that point as the final sort of?
It's actually contained in one of the versions of the guidance for the Green Deal, that if the wall upon which you're putting the insulation has relied on being able to allow vapour to transfer through it as part of its healthy work, then don't stop that vapour transfer, because it'll lead to moisture being trapped in the wall. I have yet to find anybody to actually properly calibrate this for me, and I think we're going to have to use those little wee sticky tubes on the outside to generate some data. But basically, if it's a modern solid wall with cement, mortar and impervious bricks, not really likely to be a problem. But if it's an old terraced house with lime mortar and very porous bricks, then you have potentially got a problem. It does mean that your EWI costs rise, but actually the other problem with EPS is, despite the fact that it's stupidly light, a whole house retrofit of using EPS is about 5 or 6 tons of CO2 to pay for that in terms of manufacturing that EPS. Whereas if you do it with other ones, I'm a big fan of the wood fibre, and since Suprema took over MBT and Unger started to struggle and drop their prices to go with it, and Stoco had to drop their prices, wood fibre is no longer the financial basket case it used to be. The one in between is Rockwool, but Rockwool doesn't have the same ability to even up moisture that gets in, because this is the other thing about this, is that EPS can be fine if it's all immaculately detailed, but if you get a detail failure and it gets in behind it, especially if you've got a wall that is able to transfer moisture through to the inside, then you've got a problem. Whereas I've had a failure on a junction detail with wood fibre, and all that happened was that bit of the wood fibre went a bit fluffy. We just had to pull out the bit that had gone a bit wrong, repack it. It didn't even break the render surface. The customer didn't know about it. It was all good. We've had a failure of a gutter that completely drenched the wall insulation. We just had to leave it to dry out for 6 weeks. So it's a higher cost at the outset, but I think it makes for better work in the long run, and we can avoid Fishwick.
Nope, thank you for that. And I tell you what, why don't we'll clear the deck on questions. So Patrick, if I can ask you just be brief on this question from Craig in terms of the solar roofs, is there been no replacement of tiles or slates, and it's just that waterproof membrane that's being put in?
Yes, you always have to replace some slates and tiles, because they do get broken when we go up. But we had a very specific methodology about how they were. How the panels were attached to the properties, and in terms of the membrane, we've had no issues with water ingress into the properties. So I think it's a lot about how you work with your contractors and set out the method by which, and the kit that they're using to do that.
No, That's great. Thanks, Patrick. And I'll close it there. So thank you again to everyone for attending. There will be a recording of this session, and I'll ask our speakers if they're happy to share their slides as well, and we'll be able to make that available for members on our website. Last week was Retrofit Part 1. Today was Part 2. We haven't called it Part 3, but it all ties in together. Next week we'll be looking at retrofit in neighbourhoods and the wider place-based interventions that we can that our members can be doing. From we're looking at case studies, bringing external speakers as well, and we'll be looking at how investment in our homes can also be investment in our communities, picking up on those sort of themes that we've been talking about throughout this series, but particularly today as well. Following that, there'll be a webinar on rural challenges, and finally education and engagement with residents, tying it all together. So I'd please look out on my NHC for that, and I'll make that my final point. Thanks again to Wes, Charlie, Patrick and Nigel there as well. Thanks everyone.